Physics. Topic: Capacitance. Capacitor. Capacitor is a device that stores electric charge and energy, like a rechargeable battery, but works on different principles. Basic structure of the capacitor is like two conducting plates separated by an insulator or dielectric. How it works: when connected to a battery, the positive plate accumulates positive charge plus Q, negative plate accumulates minus Q. That creates electric field between plates and energy is stored in this field. Capacitance is the ability of a system to store an electrical charge. Charge stored by the capacitor per volt applied is a constant. The constant C defines the capacitance of the capacitor. The formula is C equals Q by V. Let's do a problem. The charge in volt is given. Capacitance is charge divided by volt. Answer calculates to 5 microfarad. You have learned about conductors like metals and saltwater that allows flow of charges, and about insulators like rubber, wood, glass which does not allow the flow of electric charges through them. A capacitor uses two conductors separated by an insulator to store an electric charge. Here insulator is dielectric. Dielectric is an insulating material that gets polarized in an external electric field. Conductors act as the plates, holding the opposite charges, while the dielectric prevents the charges from jumping between the plates and increases the capacitor's ability to store charge through a process called polarization. How capacitors store charge. Let's see how capacitor stores charge without dielectric. So here two parallel metal plates are separated by empty space or air. When you connect a battery, electrons are pumped from one plate to the other. One plate becomes negatively charged and other becomes positively charged. Opposite charges attract each other and an electric field is set up between the plates. This electric field stores energy, and the amount of charge stored is proportional to the voltage applied. The formula for capacitance without dielectric is C equals to epsilon into A divided by D, where C equals capacitance, in farads, epsilon equals permittivity of free space, which is around 8.85 times 10 raised to minus 12 farad per meter. A equals area of the plates, D equals distance between plates. Let's see how capacitor stores charge with dielectric. So here two parallel metal plates are separated by glass, which is a dielectric. When you connect a battery, electrons gets polarized in the electric field. External field pushes positive charges slightly one way, negative charges slightly the other way. Molecules become tiny dipoles due to polarization. This creates an internal field opposing the external field. Net field reduces inside. To maintain the same voltage, you need to add more charge to the plates. The capacitor can now store more charge at the same voltage. The formula for capacitance with dielectric is C equals K epsilon 0 A by D, where K equals dielectric constant or relative permittivity of the material. Relative permittivity of glass is 7, so more capacitance compared to capacitor without dielectric. Also charge stored is K into C0V. Combination of capacitors. Series combination. Two capacitors C1 and C2 are connected in series as shown. The potential difference is divided between capacitors. So total voltage V0 equals V1 plus V2. The equivalent capacitance for series connection is 1 by C1 plus 1 by C2. Also the charge Q is same on each capacitor. So we can write Q by C equals Q by C1 plus Q by C2. When capacitors are in parallel, all positive plates together and all negative plates together, the equivalent capacitance is sum of all capacitance. So C equals C1 plus C2. So in parallel combination, total capacitance increases. The voltage is same across each capacitor. Since formula for charge equals C into V, we can write Q1 equals C1 into V0. Q2 equals C2 into V0. Let's do a problem. What is the effective capacitance when a 20 microfarad capacitor is placed in series with a 30 microfarad capacitor? We know for series connection, 1 by C is equal to 1 by C1 plus 1 by C2. By substituting the values, the effective capacitance C is calculated to 12 microfarad. Energy stored in a capacitor. When you charge a capacitor, you do work, like compressing a spring. This energy is stored in the electric field between plates. The formula for energy in terms of capacitance and voltage is U equals half CV squared. The energy stores in a capacitor in terms of charge and voltage is half Q into V joules. Video by Anand Mohandas.